So here we have a system of quadratic equations. The method for solving this graphically does not change from a linear quadratic system. In order to graph these in the calculator, we still need to isolate y. So again, I'll number the equations. It's slightly more complicated to get y isolated in each one, but not very much. I'm going to start by subtracting y from both sides in equation 1. Sorry, adding y to both sides, that is. And from there I can add 35 to both sides. Same basic process for equation 2. Add y to both sides. And add 11 to both sides. And now that we have y isolated, we can turn to the graphing calculator and input both of those equations. Go to y equals. We need 2x squared minus 16x plus 35 and 2x squared minus 8x plus 11. We'll graph those. And we see two parabolas. We only see pieces of them, but that's okay. We know that these intersect at least one point. Could they intersect at another point above the window that we have? Yes. But if we use our knowledge of quadratic functions and we take a look, a in both of these functions is 2. So these parabolas both have the same width. So knowing that they're the same width, they will remain the same distance apart no matter how far up we go. These will only cross at one point. If a was different, then yes, they would cross again at some point off of the window, and we'd have to deal with that. But knowing that a is the same, they're the same width, they won't cross anywhere else. To find that point, second trace, option 5. First curve, it's telling us y1, yes. Second curve is telling us y2, yes. Guess, well, the cursor's not on the screen. But based on what's given to us at the bottom of the screen, the cursor's actually at 011. 011 would be roughly on the M of Texas Instruments. So we need to move that point, move it to the right, and the cursor does come on the screen. That looks about close enough to me. And we see that intersection is at 3